And now focus your attention on this particular sphere here representing a sodium sphere. Note that it is surrounded by a red one here, a red one here, a red one here, a red one here, one inside back here which you can't see too well at this angle, but there would be one out front if the crystal would continue to grow. That is, we would say that in this lattice model, the red spheres have a coordination number of 6. They have 6 nearest neighbors. The silver spheres have a coordination number of 6. This means also 6 nearest neighbors, and they have what we refer to as octahedral then coordination. Now this represents an actual octahedron, that is an 8-faced figure, but with 6 points. Here is an octahedron. We talk about 6 points then arranged symmetrically around the very center of this particular geometric figure. I have suggested before that perhaps the best way to represent a structure such as sodium chloride, though, is to look at the spatial models in which we pack them together according to the sizes which we believe they really have relatively. That is, sodium ions are about this size with respect to chloride ions relatively. Among the structural features which have been pointed out in this model when we've seen it before, again, is the fact that each of the little dark-colored spheres representing the smaller Na+ ions are surrounded octahedrally, again we say, by 6 of the yellow spheres. Now, to make sure that we see why it's 6, let me add to the front of this another sphere here to now show you that there are 5. Remember, there's one below, and now we have 4 around this particular sphere. And I can bring another one in here to complete its coordination number of 6. And by the same token, each of the yellow spheres is surrounded by 6 of the darker, smaller blue spheres. For example, this one is surrounded by 4 of the blue spheres in this plane. There's one behind it in the interior, and I put another one out front to maintain its coordination number of 6 at the corners of a regular octahedron. And as this crystal is to grow, if it does, these will continue to pile on here in some regular arrangement. And just by means of these little magnets, let me put a few of them here to indicate a crystal growing along this particular face of the crystal as ions sit down, pluses on minuses and minuses on pluses. At least the concept here is able to explain, the concept of ions able to explain some things about this structure. In a previous lesson, we looked at this structure again, something like this, and I suggested in terms of tennis balls that we could conceive of 4 tennis balls around a central sphere. This would be sodium and chlorides, and the coordination number of 6 we indicated this way. Now this time I would like to again indicate that this is an octahedral structure, and I put an octahedron here along beside it so you can see them together in perspective. If I rotate it around so we have points toward you, here's the point of this octahedron and the point of the one made of the 6 tennis balls with the sodium ion in the center. Now, if salt is made of ions, perhaps these ions will actually move under an electric potential. That is, salt may be a conductor of the electric current. Let's try that experiment here together. We have some platinum electrodes fixed up here, about 50 volts in this particular circuit and a 10-watt bulb. Let me show you that it does conduct electric current when I bridge across here. And now, in this small crucible, I bring up some ordinary table salt, dip it in, the light doesn't light. At least that suggests that table salt in this form doesn't conduct electric current. It also suggests that a solid doesn't conduct, but perhaps we can explain this. Perhaps the ions are frozen into place, and since they're frozen into place, they can't move. Now, if they're frozen and can't move, maybe if we could break them free and let them move, that is, melt the salt, we could show that there are actually ions present, or at least that we have a conductor. What I'd like to do is a few experiments here with some melted salt, and since it takes time to melt salt at a temperature above its melting point, not too great above, we have put away 4 crucibles of salt inside this oven. Now at present, the indicator on the oven here is showing about 900 degrees on the centigrade scale. It's the bottom of the scale. The numbers are quite small, not easily read, but the pointer is between the 800 mark and the 1000 mark at about 900. What I propose to do is take out successively some containers of salt from inside this oven at the temperature, which are already in a molten state, and let you see some of their properties as I bring them out. As I open it, I can see some of the white vapor. This is actually apparently salt vapor coming out of this red-hot oven. I'm going to reach in here, bring this out, and set it out so you can watch this liquid. Let's see if I've got that a little too close there. All right, that's clear. This is liquid salt. For all the world, it looks like water at present. And we'll just let it cool a little bit here in the room, and as it cools, begin to crystallize. Now let me just shake that around a bit so you can again get the effect of a colorless liquid. It could be kerosene or water, any number of things so far as you can tell here. It has begun to crystallize just a little bit around the edge at the top. In just a moment we should be able to see the whole mass begin to change. I see some crystals now forming at the top, beginning to fan out something like snowflakes. In just a moment you should see some settling down to the bottom of the container as crystals form. Let's just watch that for a moment. As you see now, liquid salt changing over to solid salt. And then we'll look at some other properties of another container in just a moment. Well, that is not completely crystallized, but I think it's crystallized enough that you get the idea that we're working at fairly high temperatures. And in this particular case, you have seen some liquid salt freezing. Let me now remove this and bring in a second sample.